All right. Did you find the values for GC A to B at B, GC B to A at B?
172.5.
172.5 is the value for GC A to B at B, right?
A to B at B.
Okay, let's find out. GC final minus GC initial is convergency. Where to find this? So it will be 15 plus 52.5. That's it. That will be 26.
Like the first method you told, in the
Okay.
above case.
Okay. In
Like
that
you
one,
asked
we
me
were
to
not
substitute.
calculating this and this. Here, first we are finding this one, right?
Yes.
Okay. What was the first method in the previous one? What did you understand by that? This is the
Yeah,
second one.
this.
You just did ulta of this, and then you just add this one to find this. But I wanted this one, right? It's okay. Even if you found this, let's see. Where did the question go? Here it is. No problem. Drum line was 060 degree. Did you find out this direction? What was this direction?
One 172.5.
No, I see what you did. You are telling me this thing. Did you add 180 plus 52.5 or something like this?
180 minus 7.5.
You did 180 minus 7.5. All right. Where is this 180 degree direction, sir? From where you subtracted 77.5? You thought this is 180, and then you try to subtract 7.5, right?
Yes.
I feel you did this. 180 minus 7.5. But this is not the
Okay.
correct way, na? See,
Yes.
even if you wanted to subtract 7.5, see, this angle will be equal to this angle and not this one. So this is not 7.5. This one was 7.5.
Yes. Yes.
Do you get your mistake now?
Yes.
It's okay. Let's see. The first method which I told you last time, it was something that we found out this value, this one. We added this angle to get this one. My question is to find this one. It's okay. Let's find this one first. From the first method. This direction is 060 degree. This direction is 060. What will be this direction? 060 degree plus 180. Or you can simply do 060 plus 2 minus 2. 2 plus 0, 2. 6 minus 2, 4.
Okay.
Do you remember that?
Yes.
That if you have to add or subtract 180, if you want to add 180, then you do plus 2 minus 2. So the first, these are 3-digit numbers. So you add 2 to this number, minus 2 from this number, and this number remains same. If you want to subtract 180 from some number, You do -2 plus 2 and leave the third number. Okay?
Yes.
Except for the number starting from 110 to 120, 119. You just simply have to add that, add or subtract. So 060 plus 180. This direction became 240. Do you still have doubt? How did we get 240 degree?
Yes, ma'am. Yes.
Do you have doubt?
No, 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 no.
Okay. So this direction is 240 degree. Clear till now?
Yes,
This
ma'am.
angle is 7.5 degree. You want to find out this thing.
Yes.
So what will this track be? 240 plus 7.5.
Yes.
So this track was 247.5.
I'm fine.
Let's find out this one. This one is completely opposite of this 247.5. Do you agree?
Yes, ma'am.
It's just like a 180 degree. This point is 247.5. This one will be minus 180. So it will be
67.5.
what we have to do? -2 plus
Okay.
2. -2 0 plus 2 6 and else remains same. So it's 067.5. Now we have found out everything. You have to tell me in a correct order which solution is for which question. Great circle track A to
Yeah.
B at A. If you want, you can take reference from here. Great circle track A to B at A. How does it look like? And how does it look here? What is the solution?
52 degree.
Perfect.
From A to B
2.5.
at A.
Yes. Great circle track from A to B at A is
Yes, ma'am.
52.5. Next one. Great circle track B to A at B.
B to A at B is 67.5.
No. Do you see here? B to A at
B
B. How does it look
B to
like?
A. Okay, 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 okay. B to A at B. Okay, ma'am. Yes.
See, I have written with number. The fourth one is B to A at
Both
B.
one is B to A at B. Yes, ma'am.
Good. Now, see here.
It's 247.5 degree.
Very good. Now the third part. Run line from B to A.
Ran from B to A. Okay. Two. Yeah, 240 degree.
Perfect. 240 degree. Fourth part. Great circle A to B at B.
Great, sir. A to B at B. Yeah. 60, 67.5.
Very good. So now you know the values, whatever we were supposed to find. Do
Yes.
you understand the concept that great circle final minus great circle initial gives us convergency?
Yes.
We can even see it from this example. This was our great circle initial. Its value was 52.5, right?
Yes,
Our
ma'am.
final track was 67.5, right?
Mm.
This is the great circle initial. This is the great circle final. Okay.
Yes, ma'am.
So if you subtract GC final minus GC initial,
We'll get the convergence, which is 15.
very good. Do you see? We can even see from this example that great
Very
circle
good.
final minus great circle initial gives us convergency.
Okay.
The angle between them between the rhumb line and great circle track is conversion angle.
And conversion angle, which is 7.5.
Good, very good. So this was it for the theory part. Okay, let's see the example. Examples are slightly of higher level, but it's fine. Let's try with the first one. Aircraft is flying from this position. The position is
72 degrees 0 minute north, 2 degree 30 minute east.
very good.
To position 72 degree 0 minute north and 117 degree
Yes,
west.
perfect. On the
30
shortest
minutes.
path possible.
Yeah, 30 minute west on the shortest path. Yeah.
Right. What is the question asking? The initial true track, right?
Yes, ma'am.
First part. Now, we will not move to this part. First of all, you'll make a diagram for me and forget whatever we have learned today. Till yesterday, till departure, we know how to find the shortest distances, right? If you want to follow the
Yes.
shortest path, how do we go?
Mm.
Just try to make
Yes.
it. It is in the Northern Hemisphere.
Ma'am, Chilat will be 119 degree 30 minute towards west, like it's traveling from east to west. And the departure would be like
Okay. Do you want me to give some hint?
no, ma'am. Yeah, but
Do you
it
see
has
the east
started
and west
from 32 degree
points?
north. Huh?
Do you look at the east and west points? Are they not on? Okay. First, when we see the shortest distance possible, first thing we look at is are
30
the
degree.
longitudes on meridian and anti-meridian? Are they?
Yes.
Right. They are on meridian and anti-meridian, right?
Yes, ma'am.
If you want to travel the Earth from any way possible in the east-west direction, the points are 72 degrees north on anti-meridian 177.3, right?
Yes, ma'am.
On 72 degrees north, starting from this point, if you travel anywhere, like if you want to travel the whole Earth from this point to exactly its opposite point, if you move on the circumference like this, you'll have to cover 180 degrees, right?
180. Yes.
But that is the longest distance possible.
Longest.
We
Yes,
want
yes.
The shortest. Okay? If I want the shortest distance at 2 degrees 30 minutes east, right?
Yes, ma'am.
It's 72 degrees. 71, 72, around 2.5 degrees. You see, the Earth itself is saying that if you want to travel, shortest way possible is over the pole, right? Do you see the
Yeah.
shortest distance possible now? You are not
Yes.
going to move 180 degree like this on the Earth.
Okay, okay.
You'll have to travel over the pole. Now tell me the shortest distance first. What will be the shortest distance possible? Question is, what is the shortest distance possible between point A and B? 72 degrees north, 117 degrees 30 minutes east, and 72 degrees north, 2 degrees 30 minutes west. I think it is the question.
Yes, ma'am. 115 degrees zero minute.
Sujan, Sujan, from 72 degrees north, again you want to go 72 degrees north over the North Pole. So you have to subtract from 90, na? 90 minus 72. Again, this is 90 minus 72.
Oh, okay, okay, okay. Like,
Which way did you go now? Which direction did you choose, huh? Like this or like
yeah, I
that?
was subtracting. Yeah, got it, got it.
You want to go over the North Pole. So you'll have to choose the latitude. From 72 degrees north latitude towards the North Pole. Again back to, from North Pole back to 72 degrees north on the opposite meridian.
36 degrees.
Perfect. 36 degrees and then we'll multiply it by 60 and we'll get it in nautical mile, right? So this 36 degree is going to be the shortest route possible. Do you agree with it?
Yes, ma'am.
If you had traveled in the east or the west direction like that, you would have to travel at least 180 degrees. Companies don't want you to use that much fuel. They want to save fuel. So they'll ask you to travel from the pole.
Yes.
All right. Now you know what is the diagram for this question. Give the initial true track direction. Okay. You are going from this point, right?
Yes, ma'am.
This is 0 degrees east or west. This is a latitude of 72 degrees in the northern direction, in the north hemisphere. This is the eastern direction. This is our point A. 0, 2 degrees 30 minutes east, right? From
Yes.
here, how did you travel? You traveled towards the pole, right? After reaching on the pole, again you went back to the same 72 degrees north, but on the opposite side of Earth. Do you
Okay.
agree to
Yes,
this?
ma'am. Yes, yes.
So what will be your initial true direction? Where are you going? You are exactly going towards the. Do you agree to it?
Yes.
This is like a roller coaster ride. You wanted to go from point A to point B. You traveled exactly to the north, right?
Yes.
Then you came down like this towards your point B. Okay. Now second part B.
Like direction.
Do you think that we are traveling towards the north direction whole time? Just look at it.
Yeah.
Or you can look like this also. Look at this roller coaster. Do you think we are always traveling in the north direction?
Yes.
If you were always traveling in the north direction, sir, you would cross the atmosphere and reach to some other planet only. Did you never think of coming back?
Okay.
First, you went towards the north, you reached on the North Pole, but then you
Not
came towards the south also, na? That's why you reached your point B. If you did not
yes.
stop at north, if you went like this, that means you just crossed the atmosphere and went to some other planet only. And that is not practically possible for your aircraft,
Yes.
right? So now tell me, will the track direction remain same the whole flight?
No.
No. Why? Because it is changing at North Pole. We can't keep moving north. Where will you go north? Above the North Pole. You'll have to go to south now, right?
Yes.
It's just like a
So,
roller coaster. If you go up, you have to go down also. Okay? Now the third part. Give a reason for the answer given in B above. Why do you think it will not be the same? In your words, sir. Why do you think? Why do you think that the track direction will not remain same the whole flight?
yeah, since it's going from north to south,
How is it
it's
going
not
north to
maintained.
south? Climbing up, climbing up towards the north, climbing up towards the North Pole. Yay, we reached the North Pole. Oh
It's the
no,
north.
we have to go down.
Yes.
We'll keep going down. Now you reach your final destination,
Yes.
right? All right. Question number two. What is the point? What is the position of rhumb line between any 2 points relative to great circle between the same points if the points are in the northern hemisphere? What is the question? The question is asking the position of rhumb line between any 2 points with respect to the great circle track. If it is in the northern hemisphere, it will look like this. If it is in the southern hemisphere, it would
Down.
look like
Down. Yes.
down, right? So they are just asking about the position. If you are in the northern hemisphere, then rhumb line is on the south of great circle, right? Great circle is above, rhumb line is below. Similarly, for the southern hemisphere, with respect to the great circle, rhumb line is on the north, right?
The above and the great circle will
Above
be
and
the
below.
blue.
Yes, good.
Yes.
This is what they are asking. Now the next question. Question number three. The initial great circle track from this point C to this point D is this one. Final great circle track is given, and then they are asking you the longitude of that point. And you have to tell the approximate great circle track direction at this longitude. Can you make the diagram? First, tell me, first question you have to ask in the questions of convergency is which hemisphere? Where are you? In which hemisphere? Where are you?
In Northern Hemisphere.
Good. So now you have clarity in your mind. How will you proceed with the diagram? Second thing, are you going towards the eastern direction or are you going towards the western direction?
East.
Okay. If you were going in the east direction, how would you get these?
Started from 15 degrees east.
Okay, even if you don't see that, do you see the question has said initial grade circle is 300, final is 295. Happy till now? Initial is given, final is given.
In final is the convergence.
295. Now stop. You are in the northern hemisphere. If you were on east side, the value should have been increasing, right?
Increasing, yes.
But you see that from 300 it is going 295. It is
it's decreasing,
decreasing.
yes.
In the northern
So
hemisphere, it is only possible in the
west direction.
west direction. So now we know you are going in the northern hemisphere, in the west direction, and your great circle track distance is, the great circle track is decreasing. All right. Now can you make a diagram?
Convergence angle is 2.5.
Yes, very good.
And yes.
It is actually mixing two questions. Can you just show me your diagram first? You can just send me a photo.
Actually, two diagrams I have drawn.
It's okay, send me both of them.
Yes, still I'm completing.
Did you just try to make them in the eastern direction? Did
Yeah,
you?
actually, I mean, the initial before you explained it, with the diagrams.
Just make a diagram and then we will continue with the question. Did you get the same diagram now?
Yes, ma'am.
All right. Since we know that great circle final minus great circle initial is convergency, you must have found out that its value is 5 degrees. You
5.
divided it by 2 and you got conversion angle, right?
Agree.
This was the convergency. Now, what is the formula for convergency? Geelong, sine, mean latitude.
Thank you.
So good so far?
Yes.
Now, let's find the mean latitude. Latitude is 36 degrees north for C and 42 degrees north for D.
Yes, 36 plus 42 divided by 2.
36 plus 42.
39. Sine 39.
That is 39. Okay.
0.629.
Geelong, sine 39. Let's find Geelong. 5 divided by,
7.994.
we'll change it. We have to divide sine by 5 by sine 39 only, right?
Yes.
So you got 7 degrees and 56 minutes.
7 degree 56 minutes. Yes.
Yes. So the Geelong is 7 degrees and 56 minutes. Point C is given 15 degrees in the east direction. For D, you have to find point C is here at 15 degrees east. Point D is here, and the Geelong between them is 7 degrees and 56 minutes. So what will be the coordinates of this point? 15 degrees minus,
7.5.
yeah, 7 degrees 56 minutes, right? 15 degree minus 7 degrees 56 minutes. That equals to 7 degrees and 4 minutes. 7 degrees and 04 minutes.
Yes.
And we are still in the east side. Here is our prime meridian. The point D was at 7 degrees 4 minutes. The point C is at 15 degrees east. So the Geelong came out to be 7 degrees 56 minutes. So we got the longitude of point D. Did we get?
Yes. Yes. D
Good.
log. So
So we
longitude.
got longitude of point D as 7 degrees and 4 minutes east. Next, what is the approximate great circle track direction at longitude this? 11 degrees east. So whenever they ask you what is the approximate great circle distance, see, this is initial. The great circle will be changing its track like this and finally reaching its great circle final track, right?
Yes.
If you take the average or the approximate of all these great circle tracks, it comes out to be a straight line. And what else is a straight line? This one, right? For this diagram, since we are going in the west direction, so we are going something like this. The average would be this direction only, right?
Yes.
This is the average, the approximate of all GC. This will be equal to the rhumb line, this point. Since you know that this is 300 degrees and you know this is 2.5 degrees, what will this angle be? This much angle is 300 degree. This smaller angle is 2.5 degree. This will be 300 minus
7. 275 point 297.5 degree.
7.5 degrees. So this is going to be the average. Okay.
Yes.
So today you try to solve all these questions, and the practice set 2 is also uploaded on the app. So you have to
Okay.
try to solve the practice set 1 and the practice set 2.
Okay.
I know this is a bit difficult topic than the previous ones, where you have to find just the distances, the departure formula. This one is asking you about the directions as well, right? To
Yes.
find the track angles and everything. So it becomes a little complicated. But it's okay.
Yes.
You try to just revise because there's a lot of things what you have learned today. So to
Yes.
digest all of these things, you just try to make these diagrams first. If you do not
Yes.
try to make these diagrams, you would not understand what are the directions and what is happening where. Where is it increasing? Where is it decreasing? Then
Yes, ma'am.
always keep in point these 5 directions. If you do not know these directions, you won't be able to solve a single question. Then the formula for convergency. The question which we saw right now, we used here the formula for convergency, right?
Yes.
So today your work is to revise everything, try to make good notes, and solve this question. Tomorrow's
Okay.
class, you have to come with set 1 and set 2 solved. If not able to solve, we will sit and solve each and every single question tomorrow. Okay? Any doubt?
Tomorrow, do we have class? Like, just asking. Like,
I don't have any problem since we missed yesterday.